Hi, I'm Ross Smith, and I'm a Principal Program Manager within the Intune Customer Experience Engineering team. And today we're going to talk about Intune App Protection Policies with Policy Assurance. Now you may be wondering, what is Policy Assurance? In this case, Policy Assurance means successful delivery of an app protection policy to the mobile app prior to the user obtaining an access token. So by the end of this session, my hope is that you will understand what app protection policies are and how they protect your work or school account data, and how we can leverage conditional access to enforce Intune app protection policies. I always like to begin these discussions with this type of overarching view of how mobile devices are utilized. Mobile devices are prevalent within our daily lives, both from a personal perspective and from a work perspective. They are used whether we're on the go or not, when we're in our offices, when we're in our homes, while we are doing errands. And the reality is that our users expect to be able to access their data at any time from any location using any device with the apps they know and love. But from an IT perspective, our job is to ensure that that data access method is secure, because as we know, hackers, social engineering attacks, etc., will occur regardless of the type of device that the user is utilizing. And that leads us into kind of understanding what are the ways we can protect mobile devices. Traditionally, it's in the form of mobile device management, which historically has grown out of the need to protect and ensure we have PIN and encryption to protect mobile messaging data. But over time, that has grown way beyond those simple type of compliance policies to more advanced compliance policies, as well as the ability to manage and control the individual device's settings themselves, and to push down device-specific profiles like certificates or VPN profiles. In the end, mobile device management provides a holistic mechanism to manage the entirety of the device and the apps that reside on those devices. Another way to manage data on a mobile device is through mobile application management. The primary difference between mobile application management and mobile device management strategies is that in mobile application management, we are looking at protecting the apps themselves as opposed to protecting the entirety of the device. Mobile application management strategies provide capabilities to manage the app lifecycle and manage and protect the data that reside within those apps. Now, you may be wondering, what strategy is right for you? It may be a combination of both. As an example on this slide, I indicate that mobile device management is ideal for corporate-based scenarios where the device is owned by the organization, whereas mobile application management strategies are ideal for situations where the user owns the device themselves. But that doesn't mean it's an either or type of strategy. You can leverage mobile application management strategies on top of enrolled devices. And in fact, with Microsoft Endpoint Manager and Intune, our mobile application management strategy, Intune App Protection Policies, do just that. They can be applied regardless of the device enrollment state. The mobile application management strategy that Intune has implemented is known as App Protection Policies. Our App Protection Policy model is grounded in the concept of the identity, just like the rest of the Microsoft 365 cloud, because we recognize that users have multiple personas. They have a work identity, they have a personal identity, and we need to be able to ensure that within our apps that we are applying protection at the work or school account identity, and while leaving the personal identity unaffected. Because in our mobile apps, we've invested in a structure that enables users to add both their work accounts and their personal accounts into a single app so that they can have a holistic view of their life. For example, within Outlook, the ability to see my calendar information that spans both my work and personal so that I have an end-to-end view of what my day looks like. With app protection policies, we've broken things down into three key areas: conditional launch, access requirements, and data protection. You may be wondering how we can ensure that devices are healthy in the event that we're not enrolling the device. This is where our conditional launch capabilities come into play. We can evaluate whether the device is rooted or jailbroken. We can leverage mobile threat defense vendors and Microsoft Defender ATP to provide more holistic information on the device health. We can look at other device-specific characteristics like the operating system version, the device model or manufacturer, the app version. And we can make, as admins, we can make intelligent decisions on how we want to handle if any of these conditions aren't satisfied. For example, if the device is jailbroken or rooted, we could make a decision to wipe the work or school account data from that app while leaving the personal account data within the app. Or in the case of like an operating system version, we could make a recommendation to warn the user that they're running an unsupported version of the operating system and that they should upgrade. Or in the case of like the device model, we could outright block access and prevent the user from adding their work or school account data in the event that they're using a model that as an organization we don't want to support. Likewise, with access requirements, we need a method to ensure that the work or school account data access is controlled, because if we're not enrolling the device, we cannot rely on the existence or strength of the device PIN. So with access requirements, we can apply a PIN in order to access the work or school account data within the app. That can be a simple PIN, a complex PIN. We can control the number of digits within that PIN, whether you utilize credentials, and whether you support biometrics. And of course, with access requirements, we have inactivity timers, which define the frequency that the user should be prompted to enter their PIN or utilize biometrics after a period of inactivity, or what we should do in the event that the app hasn't accessed the Intune service after a period of time. We can block access and/or wipe data as necessary. And then finally, with data protection, this is where we implement controls like encrypting the work or school account data within those apps using algorithms provided through the Intune SDK. But we don't stop there. We also have mechanisms to control how data can be transferred between apps that have an app protection policy and apps that do not have an app protection policy, or get even more granular and control how data can be transferred between the work or school account identity and the personal identity, and even make controls around ensuring that when tapping on a web link within the work or school account, that we transfer that web link to a protected web browser so that data cannot be leaked through a browsing session. And of course, it goes without saying that we have selective wipe capabilities. I mentioned how through inactivity and conditional launch controls, we can initiate a wipe, but the admin also has the capability to initiate a remote wipe, such that when next time the app launches, the wipe is initiated. You may be thinking that there are a lot of settings available within the app protection policy. Well, the good news is that several months ago, we released the App Protection Policy Data Protection Framework, which is designed to help you identify the appropriate settings that you should configure for your work or school account data. We've broken this down into 3 distinct configuration levels: basic data protection, enhanced data protection, and high data protection. The basic data protection configuration level is designed to be an entry point into implementing app protection policies. This configuration level mirrors effectively Exchange Online mobile device mailbox policies, which you may be utilizing today, by introducing, for all of the mobile apps that can be protected by an app protection policy, PIN and encryption settings. It also introduces a number of conditional launch settings like Android device safety net attestation, which ensures that the device is healthy. The enhanced data protection level includes everything in level 1 and introduces our data protection mechanisms like data transfer, protecting and ensuring that data cannot be transferred from a managed app to an unmanaged app. And as well, introduces minimum operating system requirements. And finally, we have our high data protection configuration level. This includes everything in level 2 and introduces advanced data protection mechanisms, enhanced PIN configuration, and mobile threat defense. We believe that the majority of your users should fall into the enhanced data protection configuration level, while you can utilize the high data protection level for those users that access highly sensitive information or are high risk or regulated users. You may be wondering, how do you deploy these configuration levels? Well, the good news is that we've implemented templates that you can deploy via PowerShell and have the policies created. And then you only need to assign those policies in order to have them take effect. We are also rolling out guided deployment scenarios that introduce a simple wizard-like user interface that you can use to deploy either the basic data protection or the enhanced data protection configuration levels. So now that we understand what app protection policies are and how they can be used to protect work or school account data, we need to understand how we can enforce those app protection policies. And that's through Azure Active Directory Conditional Access. Conditional access is nothing more than a policy-driven approach that applies an if-then model to make decisions based on the authentication request of whether to allow access or to block access. And we do that by evaluating a set of assignments, like who's attempting to authenticate, what cloud app or endpoint they're attempting to authenticate against, and specific conditions of their authentication request, like what location are they attempting to authenticate from, what device platform are they utilizing, what client app are they attempting to use to authenticate with. And then we can even look at advanced scenarios like risk of the user's authentication. In the event of a user risk, we know that the user's account is potentially compromised and we can force a password reset. Or with sign-in risk, we can take the entirety of their authentication requests and prior authentication requests and make an intelligent decision as to whether that sign-in attempt is risky or not. Finally, after evaluating the assignments and conditions, we can make a decision of whether to block access or to allow access. And if we allow access, we have further granularity. From the perspective of mobile devices, we have three key grant access controls that we can utilize. First and foremost, we could look to see if the device has been marked as compliant. As its name implies, this means that the device is not only enrolled, but is also compliant from a compliant policy perspective or from a mobile threat defense vendor perspective. And then finally, we have our require approved client app and require app protection policy grant controls, which are really geared for app protection policies. The require approved client app grant access control has been around for a number of years and is a statically defined list within Azure Active Directory of Microsoft mobile apps that have integrated the Intune SDK. What this grant access control does not do is validate that the Intune SDK is in use by the app attempting to authenticate, or if the user is licensed for Intune. And that's where we've now introduced a new grant control at the end of 2019, the Require App Protection Policy. This grant access control addresses the deficiencies in Require Approved Client App and works with both first-party Microsoft apps and third-party apps that support Intune App Protection Policies, including line of business apps. This grant access control performs policy assurance. And as I've defined previously, that means the successful delivery of an app protection policy before Azure Active Directory grants an OAuth access token. But how does that work? So let's take a device. On this device, our user has Outlook installed, and she wants to add her work or school account to Outlook. The very first step is she attempts to authenticate against Azure Active Directory. If she does not have a broker app installed, Azure Active Directory will require her to install a broker app in order for her device to be registered to apply conditional access. On the case of iOS, this broker app is the Authenticator app. For Android devices, this broker app is the Company Portal app. Once she installs the broker app, she can register her device. Once the device is registered, the Intune SDK can check into our location service within Intune to determine where her account resides within our scale units. The SDK will then register the user plus this particular app, Outlook, with the App Protection Policy Service, and the App Protection Policy Service will return an APP token. The Intune SDK will leverage that APP token to query for app protection policy information for this user. The app protection policy is then delivered to the SDK, and the SDK acknowledges receipt. Now, behind the scenes, Azure Active Directory is checking in with the Intune App Protection Policy service to see if policy acknowledgement has occurred. It isn't until after step 5 that is a positive return back to Azure Active Directory. And it's at that point that the Azure Active Directory Security Token Service can issue an access token back to Outlook, of which Outlook can then leverage that access token to access Exchange Online in synchronized mail. Now, it's important here to understand that from a policy assurance perspective, 4 key things must occur. First and foremost, the user must be licensed for Intune. The user must be assigned an app protection policy. The app protection policy must include the app in question attempting to authenticate. And then finally, the app protection policy must be successfully delivered to the app, and the app or SDK must acknowledge its receipt. If any one of those 4 things does not occur, then step 7 will fail. A security token will never be delivered to the app, and thus the user will never be able to access their data. We're in a state of transition between the require approved client app and the require app protection policy grant access controls. And not all apps support the require app protection policy grant access control today. It requires investment within the apps. They have to integrate an authentication library. They have to integrate the Intune SDK, and they have to make targeted code changes to support this new conditional access paradigm. So to support this transitory period, where we have a set of apps that don't support this new grant access control, and we have a set of apps that do support the require app protection policy grant access control, you have to make targeted changes within your conditional access policy. Specifically, you have to include both grant access controls with an OR operator. What this does is, behind the scenes, Azure Active Directory is aware of which apps support the require app protection policy grant control and which apps do not support it. So if an app like Outlook, which supports require app protection policy, attempts to authenticate, then the require app protection policy grant access control will be adhered. In the event that an app does not support that grant control, but is on the require approved client app grant access control, then that is the grant access control that will be applied during that authentication request. Either way, if an app supports one or the other grant access control, access will eventually be provided, assuming all the conditions are met. You may be wondering which apps support require app protection policy grant access control. The good news is that the majority of the Microsoft productivity apps support this. This includes Edge, OneNote, OneDrive, Outlook, Office, Word, Excel, PowerPoint, SharePoint, Teams, and others. Likewise, we also have support with several third-party apps, including 9 and Multiline. And of course, you can integrate this with line of business apps as well. All you have to do is integrate the Intune SDK. For more specific information on how to take advantage of the grant access control with your line of business apps, check out our Intune SDK integration documentation on docs.microsoft.com. You may be wondering how you can troubleshoot this in the event that there is a failure for one or more users attempting to authenticate with this new grant access control. The good news is Azure Active Directory sign-in activity logs provide a wealth of information. For example, here we have James attempting to authenticate against his tenant with an Android device utilizing Outlook Mobile, and yet the authentication request failed. We can see here in the sign-in report that the failure reason is because James did not install the broker app and complete device registration for his Android device. In the event that this information doesn't help you resolve, click on the Troubleshooting and Support pane and initiate a support ticket with Microsoft Support, where we can investigate utilizing the request or correlation IDs and help you resolve those particular issues. Now that we understand what an app protection policy does and how we enforce it through conditional access, I thought it would be good to outline the key conditional access policies you should deploy to protect your mobile device access. The core requirements to implement the next 4 policies are ensuring that the users are licensed for Intune and are assigned to an app protection policy, and that the apps you'll be utilizing are defined within your app protection policy. So our first policy is around enabling support for the productivity apps, like all of the Office mobile apps. So from an assignment perspective, we're going to target our end users, and we're going to target our cloud app. In this case, we're going to target Office 365. Now, you may be wondering, why not be more granular and target things like Exchange Online or SharePoint Online or Teams? And the reality is that many of our services now have interdependencies amongst one another. For example, with Teams, Teams has integration with both Exchange Online and SharePoint Online. You cannot enable access to Teams while blocking access to Exchange Online, for example. That will result in the failure of the user being able to access Teams in any type of client. Likewise, from a client perspective, we're building productivity scenarios within the apps that span the services. For example, with Outlook, we now support the capability to create to-do tasks, to create and join Teams meetings, and we support OneDrive integration through our file picker. So we have the capabilities to enable rich productivity experiences within the apps. And as a result of that, you need to be able to allow your users to access all of those endpoints on their mobile devices. Hence why we recommend utilizing the Office 365 Cloud App endpoint. From a condition standpoint, we're going to focus on 2 key conditions: device platform and client app. We're going to target this conditional access policy against iOS and Android devices, and we're focused on modern authentication capable apps. This is an allow policy, so we're going to take advantage of our grant controls, require approved client app with an or operator, and require app protection policy. The end result here is that if Jane attempts to authenticate against the tenant with Outlook Mobile, and Outlook Mobile successfully receives an app protection policy, then an access token will be granted through this conditional access policy, and Jane will be able to access her messaging data within Outlook Mobile. However, if Jane were to attempt to set up a modern authentication capable ActiveSync client like iOS Mail, Jane would be blocked, and Azure Active Directory's response would indicate to Jane that she needs to use an approved app. You also need to think about mobile browsers, because as your tenant is now in the Microsoft Cloud, you have the capability to use web endpoints to access services like SharePoint Online, Outlook on the web, or even Office Productivity Suite online. So we need to target and ensure that access via a mobile browser is protected. Now, ideally, while I'm calling this out as a separate policy, this could be collapsed into the prior policy as a single policy. But for the purpose of the discussion, I thought it would be good to highlight it as a separate example. So with this policy, there's only a single difference compared to the prior policy, and that is the client app is set to a browser. The end result here is if Jane uses Edge and Edge successfully receives an app protection policy, then Jane will be able to access core resources like Outlook on the web or Office.com or OneDrive for Business through the Edge mobile browser. However, if Jane is utilizing a third-party browser like Safari or Chrome or any other number of popular third-party web browsers on mobile devices, when she attempts to authenticate against a tenant resource, that will fail, and Azure Active Directory will report back that she needs to use an approved app. Now, these 2 policies handle modern authentication capable clients like a web browser and other modern apps. What it doesn't cover is legacy authentication, so we need to address that scenario. The first legacy authentication scenario we need to address is basic authentication Exchange ActiveSync clients, which there are many clients out there in the wild, especially on the Android platform. From an assignment perspective, we're still going to target our mobile users. From a cloud app perspective, we could target either Office 365 or Office 365 Exchange Online. The reason why you can target Exchange Online in this policy is because Exchange Online is the only cloud endpoint that supports the Exchange ActiveSync protocol. From a condition perspective, we're only going to focus on a single condition, and that is the client app. And that client app condition is going to be scoped to Exchange ActiveSync. We don't need to worry about device platform in this case because we want to apply this policy against all device platforms. And in fact, there are ActiveSync clients on mobile devices that don't always accurately report the device platform. So we need to be more broad in this policy application as a result. Now you may think this may be a straight block access type of policy, but in fact, I'm going to trick you up by telling you it's an allow policy. In this allow policy, we're going to leverage the require app protection policy grant access control. Why? Because if the ActiveSync client is not defined in an app protection policy, the ActiveSync client's request will ultimately be blocked. And in fact, it's through the use of this grant access control that we can actually guide the user along the correct pathway. When Jane attempts to set up her basic auth ActiveSync device, the profile setup will appear successful, but when Jane launches the Mail app, she'll actually see a quarantine message. ActiveSync is designed to support the ability to quarantine in Exchange Online, and we deliver distinct quarantine messages based on the responses returned by Conditional Access. So in the case of the Require App Protection Policy Grant Access Control, we deliver a quarantine message that tells Jane that she needs to install Outlook. The other grant access controls can deliver different messages. For example, Require Multi-Factor Authentication would deliver a quarantine message that tells Jane she needs to use an app that supports multi-factor authentication. If we had used the outright block policy, we would have delivered a quarantine message that just indicated that the device connection was blocked in the contact or administrator. We want to guide the user along the correct path, which is why we created this policy in this manner. Finally, we need to think about all of the other clients out there that only utilize legacy authentication. Many of these are messaging clients like support for POP or IMAP or Exchange Web Services, but we also have to deal with services like PowerShell. So we need another policy that outright blocks legacy authentication, and that's this policy. Once again, we target our users like Jane, we target our cloud endpoint like Office 365, and from a condition perspective, we're going to target client apps and the other client property. Unlike ActiveSync though, these other protocols don't have an architecture that supports quarantine. So this policy is an outright block policy, which will trigger an access denied response back to that particular client. Now I do want to caution you with this policy. This policy is broad. It affects all device platforms and it affects all forms of legacy authentication. Before implementing this policy, you want to be sure that you understand what legacy authentication clients are out there and being utilized within your environment. Thankfully, you can do that through Azure Active Directory sign-in reports. Validate what's in use in your environment before implementing a broad policy like this. You may need to start out with a granular policy and focus on particular device platforms as you upgrade your clients to modern authentication. So keep that in mind. Now that we've gone through what the conditional access policies are, how we leverage conditional access policies to enforce app protection policies, I thought it would be good to kind of walk this through both from an administrative perspective and an end user perspective. To start, let's review our conditional access policy. In this policy, we're targeting a specific set of users via a security group that are attempting to access the Office 365 cloud endpoints. From a condition standpoint, we're targeting Android and iOS devices that are leveraging modern authentication capable mobile apps. This access control will allow access provided that the authentication request meets the provided assignments and conditions and leverages one of the two grant access controls, require approved client app, or require app protection policy. Now that we've reviewed the policy, let's see what the experience looks like from the end user perspective. Here we have Joanna's device. As we can see, Joanna's already added her account to the Authenticator app and set up multi-factor authentication. Now Joanna would like to access a document through OneDrive on her iPad. So she's going to launch OneDrive. And she's going to enter her credentials. She'll begin by entering her email address. The Authenticator app will launch, and she'll enter her password. At this point, she will then switch back to the Authenticator app. Get her code. And now she's prompted to register her device in Azure Active Directory. She registers her device, and now we can begin seeing the App Protection Policy Conditional Access flow. She's prompted to restart her app, at which point she restarts her app. The App Protection Policy Conditional Access flow resumes. We can see here we're waiting for App Protection Policy delivery and application. We now see that the app is initiating protection. And now we see that the app protection policy has been successfully applied. She taps OK. And now she's prompted to create an app level PIN, which is defined in the app protection policy. And at this point, Joanna now has access to her documents in OneDrive, and these are protected through an app protection policy. Hopefully with that demo, you now understand how this works end to end. So in summary, I hope this session has helped you understand what app protection policies are and how they can be used to protect work or school account data on mobile devices, independently of whether you choose to enroll those devices or not, and how you can leverage conditional access to enforce app protection policy application prior to your users obtaining their access tokens and blocking apps that don't support app protection policies. Thank you for watching, and if you have any questions, please don't hesitate to ask. We're here for you.